Hi, welcome to AWS Security Info. My name is Phil Massain, and today I want to talk to you about identity and access management. Let's just dive in and start looking at the console. So you'll find identity and access management under the security, identity, and compliance section. We can go into IAM. All right, so let's look at the different sections we have in IAM. I'm going to start with users. So in users, you can create a username or an identity within AWS that will basically allow you to connect to the AWS services. Simply, you can just go to add user. You can give it a username. I'm going to call him Bob. You can decide whether this user has programmatic access or console access. You can generate a password or give the user a password. You can set whether the user has to change the password at the next logon. You can assign some permissions and basically get the account created. All right. So with this password, the user will be able to log on. So we can see I've got my user Bob created. There's a nice password that was created for the user. There's also an access key and a secret access key. And excuse me, these will be used if you want to connect programmatically to the account. So don't worry, the account will be destroyed even before the video gets posted. So none of these accounts will be accessible afterwards. So here we have a user. This user doesn't have any permissions at all. So what we can do, we can add the user to a group. A group is simply a collection of users. So we can create another user, another group in here. Maybe we call the group, I don't know, purchasers or whatever you want to do it. You can call the group anything you want. And then within AWS, you can attach a policy. Basically, attaching a policy means that whatever permissions is defined inside a policy, this group will now inherit that. So we can see we have some various policies in here, customer managed. There's no customer managed policy yet, but later on in the session, we will be creating a policy. So let's just go and create the group. So I've created a group now. The group is empty. There's no users in it. There's no permissions in it. And that's okay. I can add my user to this, the user I just created. I can add Bob to this group. And there we go. The user is now attached to this group. Excellent. Okay, so then we talked about policies. Now, a policy basically defines what a specific entity could do. Doesn't mean they can do it. It's just a document that describes what is possible. So if we look at the administrator access policy, and you'll see the permissions in here. And basically the statement says, allow all actions on all resources. And that's basically what administrator access means. You can do anything to anything. Let's look at another policy. Let's look for one that's, all right, let's look at Chime read only and see what the JSON says here. So here we have three actions: Chime list, Chime get, and Chime search available phone numbers. Okay, so list and get are basically read-only access. So with this, whoever has this policy will only be able to basically view items within Chime. All right, so the Chime service you can only view. You won't be able to do anything. You can't update or put or post. You can't do anything like that. You can only get information. All right, so this is basically a read-only policy. This policy is not attached anywhere. So you can have a policy that says whatever you want, unless the policy is attached either to a user, a group, or a role, that policy will not be effective. All right, so keep that in mind. Let's talk about roles. What is a role? A role is like a user account. Okay, think of it that way. So here I have a user, here I have a role called AWS Service Role for Amazon SSM. So SSM is a Systems Management Server. And what it says is that this service, this SSM service from AWS can become this role. Looking at the role, I can see it is attached to a policy. And in this policy, this role will get certain permissions. It can cancel, get, list. It can do a couple of things against all resources. Okay, and there's a few things in here that this specific role can do. What does this mean? It means that whatever we have in a role could get access to our AWS account. So whenever you look at the security posture for your account, don't just look at users, because a user alone is very limited. If you're really doing AWS right, you will potentially have, for example, you'll have a role that might be getting access from SAML. So you may have an Active Directory or some other SAML system where you can obtain credentials, and this will allow that entity to authenticate against your AWS account. So it's quite important to look at your roles. If any rogue roles get created and you're not aware of it, you could inadvertently have someone gain unauthorized access to your account. Okay, so keep that in mind. I just want to also touch on account settings. This is where we can specify things like your password policies. So password policy, you can specify what your minimum length of your password should be, whether we want to have uppercase, lowercase, allow users to change the password, prevent password reuse, etc., etc. So we can define all of these things. Keep in mind, though, that the password policy is only applicable to users created within IAM. If you are using roles and you're using federation from Active Directory, then this password policy does not apply. So very important, keep that in mind. The password policy also does not apply to your root account. So if for whatever reason you change the root password will not be adhering to this password policy. So keep that in mind. Okay, now let's do a bit of a demo. What I want to do, I'm going to spin up an EC2 instance, and I want the EC2 instance to be able to upload and download files from an S3 storage account. Now, with some customers, I've noticed they tend to create an access key. So they would go and create a user account for that server, for a web server, whatever it may be. They'll have the access key, and then they will embed the access key into some script. And this script will then allow the EC2 instance to log on to S3 and AWS and do all sorts of things. That is the wrong way of doing it. If you have access keys used within your AWS account, don't do that. That's extremely risky. And by using access keys, you run the risk of having the access key embedded in source code, and the source code can then end up in GitHub, and then some adversary might be able to scrape that out of your GitHub repo and then log onto your account with those credentials. And that has happened quite a few times. Fortunately, AWS is also scanning GitHub, specifically GitHub, to see if someone is posting access keys and credentials into GitHub. If they do find that, there is a risk that they might disable your account. So better not risk that, don't use that. Now, IAM governs everything within Amazon, okay? Sorry, in AWS. So if we're talking about IAM and we're talking about something like EC2, we can actually set up an EC2 role that will allow the instance to log on to AWS and basically inherit permissions to perform actions on your behalf. So let's do this as an example. Let's do a test. So first of all, I'm going to create my S3 bucket. So let's create something that will potentially be unique. I'm going to use Masain Test. Hopefully that does not exist. Okay, Masain Test in Sydney because that's my closest region. I'm just going to leave everything as is. Block all public access. That's fine. Go and create the bucket. And there's my bucket. This bucket is going to be nice and empty. There's nothing in this. Great. Now let's go and spin up an EC2 instance. I'm just going to search for EC2. If you don't know, EC2 is basically the compute service that will allow you to spin up virtual machines. So I'm going to launch an instance. I'm going to pick the Amazon Linux AMI. Just a T2 micro, which is free tier eligible. So if you spin this up for a few hours, there won't be any issues. Let's look at some further instance details. I'm going to leave everything pretty much as is. I just want a stock standard system, okay? Everything just going to leave it as is. Just confirming that my subnet will auto-sign a public IP, okay? Now, for the demo, I'm going to leave it like this, but in a real-world scenario, you're probably going to disable this, okay? It is a best practice not to assign public IP addresses to instances so that you have them segregated and then use a load balancer. Keep in mind, load balancers usually cost a bit more, but for us mere mortals, that don't have huge corporate budgets behind us, we just want to use this in the cheapest way possible. Storage, just going to use the default 8 gig. Not going to have too much data on this machine to begin with. The security group, I just want to allow port 22. So I'm just going to create a new security group for this test. That should be fine. Go ahead and launch. Okay, now I'm not going to run through how to create a key pair. I would assume that you would know how to do this. Okay, this demo is about the AMI, sorry, the EC2 instance being able to connect to S3. All right, so you should be able to know how to do this already. All right, let's launch this instance. Okay, instance is now launching. Let's give it a few seconds. It will be starting up. Okay, I've got the public IP address for this already. So let me just grab this. Grab the public IP, which I'm going to be using in my PuTTY session in a sec. All right, it says it's running. Let's see if I can actually log on to EC2 now. Not yet. Still not active. Let's try again. Ah, there we go. And the instance is alive. Great. All right, now, there's probably all sorts of things we want to do, like doing the updates. You know, we can do a yum update all, sorry, sudo. Okay, it seems like everything is, sorry, I'm actually an Ubuntu guy. I'm not too familiar with this instance. Let's see if we can just do a quick yum update. Again. Okay, a couple of things we can update. Let's do that update quickly. It's nice to have everything patched so we don't run into issues. And while that's running, I'm just going to change the terminal so it's a little bit easier to view. Where's that appearance? Okay. Great. Now, let's have a look. You should know about the AWS command. AWS is the AWS command line. And the reason why I've specifically picked the Amazon Linux image is it already has the AWS command line installed. I was playing around with Ubuntu the other day, and it did not have the AWS command line installed. I had to manually install that. But you could use any Linux version. You could even use it on Windows as well. Okay, so let's have a look. AWS S3 LS. Show me everything in S3. And it says, I need to create the credentials. Now, typically you will go AWS configure. It'll ask you for your access key, the secret key. You'll paste all of that in, and then it should work. I will not recommend you doing this, okay? You could probably do this if you use this as a workstation, if I can put it like that. And if you need specific access to your AWS account and you want to do stuff from the command line, this is a nice and convenient way of doing it, but it is risky. So as much as possible, I will not recommend you using this. So we do have this problem where we cannot get to the S3 account. It doesn't like us doing this, okay? But we want to be able to see that account. So if I want to be able to look at my test bucket, we're not able to do that. So how would we actually fix this? Let's go into IAM. So first, let's create a policy. So I'm going to create a policy for my test. Now we can do it a few ways. You can use the visual editor, and if you're new to the JSON code, then this is probably not a bad way of doing it. Or you can just go straight to JSON. Now let's do it like this. I want the S3 service. I want all S3 actions. Now, don't leave it like this. Don't say S3 with all resources. This will basically give this policy access to every single S3 bucket in this account. I want to be very specific. Okay. Now let's add the ARN. My bucket was Massane test. Okay, that should be it. But I also want to have all files. Okay, now let's review, give it a name, my test policy, create the policy. Now, keep in mind, we are just creating a policy. This policy is not attached anywhere. So if I filter this now to a customer managed policy, I'll see my test policy in here. And there's the JSON, okay? Get, put, get list, and there's all sorts of actions that is created now. But specifically, this is the one that I care about. All S3 actions against this specific bucket, okay? So this is basically what the policy will do. But the policy on its own doesn't do anything. Now we're going to create a role. So I want an AWS service, EC2, to be able to do stuff for me. So I've picked EC2. And now I'm going to attach my customer managed policy. So my test policy. Okay. My EC2 role. And this is give my EC2 role access to the Masain test S3 bucket. Okay, and create the role. There's my role. This EC2 service can execute it. My EC2 role, I can see the policies that's attached to it, and that looks all pretty. Great. Now I should be able to see this. But it still fails. Why? I've just created the role. The thing is, we haven't attached the role to the EC2 instance yet. So let's go back to EC2. We see our running instances. So this is the instance we just created. This is the one we're running on now. So right-click on it, instance settings, attach or replace IAM role. And you'll see here at the bottom, okay, here we have an IAM role that's currently blank. There's nothing in there. So now I'm going to attach the role. I want my EC2 role. This is the role we've just created. And apply. And we go back. Now I see a different error, okay? It cannot run the list objects v2, but at least the file is there. At least we're getting something. Let's see if we can do something here. Hello, welcome to AWS Security Info. Let's create a little file. Now let's see if we can copy the file into S3. Copy that file to S3 Masain test.txt. What did I do wrong? Sorry, I forgot to say copy. And the file went. Let's go and have a look at S3. There's my test bucket. And there's the file we just uploaded. Let's try it one more time just to make sure it wasn't a fluke. Hello again. And AWS S3 copy hello.txt to S3 Masain test hello.txt. The file uploaded, do a refresh, and there's hello.txt. So let's go and do a download of this file. Just open the file straight away, and there it is. Hello again. All right. So to recap, this EC2 instance did not have any credentials attached to it. Okay. We are using the native services within AWS that will grant this instance access to whatever services we've given it. We can go back into IAM. We can update the policy. We can look at our policy that we've created for this role, okay, which is under our customer managed policies. And we can update these permissions, and these permissions will then grant the EC2 instance additional access. So as a best practice, do group your policies and roles together. So I like to have one policy per role. That keeps it nice and neat and clean. Have one policy role grouping per job function. So for example, if you have a web server and the web servers will all work the same way, create one role for a web server and one policy for that web server. This will allow you, as you scale, if you start using auto-scaling and have multiple web servers popping up, then all those web servers can use the same role and they will inherit the same permissions. So that way you are not restricted with creating policies that are difficult to manage. And that's it for today's demo. So thank you very much for joining. If you have any questions, feel free to reach out to me. And if there's anything else you'd like to talk about, feel free to chat to me on Twitter. Thank you. Cheers.